Hello everyone, hope you're having a great day and I welcome you all to this day 4 of AWS series. Today's session is about Elastic Compute Cloud. This session is going to be about computing services on AWS. So let's check the agenda for this session. In this session you will learn what is EC2, and moving further we'll talk about different types of instances on AWS, how to configure instances on AWS, what is an AMI or Amazon Machine Image, and we'll also talk about how to create an AMI, and we'll sum up this session with public IP versus elastic IP. So that's all with the agenda. Now let's start the session. Before we begin, subscribe to Intellipaat and don't forget to press the bell icon to get more updates.
Now, what is EC2, by the way? EC2 stands for the Elastic Compute Cloud, and it is a level at which a system. So what is elastic, by the way? See, you will see elastic term a lot of times in most of services, not most of them, like Elastic Compute Cloud, Elastic Load Balancer. So elastic is very common term in AWS. Now, what do you mean by elastic? Say elastic means it can grow and shrink. Now, if you take an elastic band, right, you can grow it, and if you leave it, it shrinks, right? So it is the level at which a system is able to adapt to workload changes by provisioning and deprovisioning resources such that the resources meet the current demand as closely as possible. Elastic means that if there's a high demand, you get the things very quickly on demand. If you don't need them, get rid of them, right? So it gives you flexibility. What happens in a data center environment that to achieve elasticity is a kind of a dream. So what happens in elasticity is that it is quite essential that in a data center environment, in your own environment, if you want to get the elasticity, it is near to impossible because it's very hard to predict that how many servers you need to manage that service at a large scale. So elasticity means that it gives you the flexibility, the capability to grow or shrink your architecture, to grow or shrink your number of resources, to increase or decrease the number of resources based on the patterns of the incoming traffic, demand, and different use cases. So for example, if you have low number of users, then you need less number of virtual machines. If the amount of user base grows overnight, then in that case, you have to bump up the number of instances overnight. You can do it on the fly. Okay, so what happens is that you can get access to thousands of servers on the fly, and that's the purpose of the elasticity is. So the users traffic is increased, which means that you have to bump up the number of databases or even the front-end instances immediately. You can get it on the fly. Now, again, I said before, in your business environment, this is close to impossible. You can't buy 1,000 of servers overnight and install them on the data center and make them operational. Near to impossible. But in terms of business use, in terms of cloud computing, it is achievable. You can get as much as you want, or you can get rid of as much as you can get rid of very soon. Fine. So you get the things at your disposal. Okay. Now, in the first situation, the traffic increased, the number of instances or the number of databases at the backend, they were increased, or the virtual machines increased. But as there's a dip in the traffic, as the demand decreased, you shrink down the number of resources that you previously need. So this concept, this principle is called the elasticity. Fine. Okay. The very first thing I will do is that before I launch the instance is that I'll discuss with you this concept, the AMI or the Amazon Machine Image. See, what's that? See, right now, for example, you have a machine with you, a physical machine. It's a physical server, maybe a computer, maybe a laptop, maybe a smartphone, any device that's there with you. So AMI stands for the Amazon Machine Image. So what is that? So if you have a physical server with you, maybe any device, a laptop or a computer, a production server, a desktop, and I ask you to install an operating system upon it. You can very easily do it on the fly, and you can install the OS upon it. But if I ask you that, okay, now install the operating system or software upon a virtual machine in a separate data center that you don't have access to. You need to install the operating system, the packages, and the software upon the virtual machines or the EC2 instances that are running in the confinement of the Amazon's cloud infrastructure. So what's the solution? The solution is the AMI, that stands for Amazon Machine Image. Now, it contains the information which is necessary to launch an instance, including operating system, architecture, virtualization type, storage, what's the storage that you need to get access to, what type of storage you need to add on to it. It's like you can see that it's an entity which encapsulates the operating system, services, application, and scripts. When you execute that package, it installs everything upon that instance. Now, what's an EC2 instance? It's a virtual machine which has certain type of compute capacity, RAM, storage, or without any clicks. Now you have to, without any clicks can also be done. If you use auto scaling and automation, then you don't have to click anything. That's right. So the thing is that you need to have the AMI. If you don't have the AMI, then you can't install the software components upon the instances. Okay, I'll do one thing. I'll start with the launching process, and in that journey, in that midway, I will start making you understand those concepts. Now you have to bear with me. You have to be patient enough. Now I'll be skipping some of the concepts that are advanced in nature or that are out of the box. See, if you go on AWS page, you will see so many services out there. No one on it who's working on AWS will know all the services, right? Even in EC2, you will see so many things that will attract you. I will only discuss those services that are within the curriculum. Yeah. So I just go to the EC2 right now, and you will see that we just went to this page. Now, in order for the this thing to work properly, you have to make sure that you switch to an appropriate region of your choice. So because the instances are the region-specific resources, so you have to switch back and forth between different regions so that you can decide upon that, okay, in which region you want to deploy your EC2 instance into. Okay, so I'll do one thing. I just go ahead and click on launch instance. Okay, no, IAM is not region specific, but the instances are. So now before you can deploy the instance, you can see that these are the availability zones that are available in Mumbai. So 3 data centers. You can see the service is operating normally. Okay, so this is called the instance dashboard or EC2 dashboard. Now, on the left-hand side, you will see there are a bunch of options out there, and there's so many options. We'll discuss some of the options in detail on the left-hand side, and I'll try to cover almost all of them. Now, the thing is that I need to click on launch instance first and click on launch instance once again. The very first option that you're being presented with is the AMI, that stands for Amazon Machine Image. Okay, let me do one thing. Let me switch back to Virginia and show you that thing. So this is the page where you can access the AMI or the Amazon Machine Image. Now, what's an AMI? AMI stands for Amazon Machine Image. As you can see that it's a template that contains the software configuration, including operating system, application server, and applications. Now, these things you need to launch your instance. Fine. You need an operating system. It can be Linux or Windows or Mac OS. Nowadays, we also have Mac OS as well. And we also have different flavors of Linux distributions like Ubuntu, Red Hat. Okay. Now, the thing is, on the left-hand side, okay, these are the quick start AMIs. Now, these are the AMIs that we'll be using just for the demonstration purpose. You will not be using them in a business environment, to be very frank and honest. This is just for the purely hands-on and just to get your feet wet or get your hands dirty. Okay. Now, the thing is that there are two types of virtualizations, PV and HVM. We don't have to go into the details. We don't have to get and understand the para virtualization type or virtualization type of these AMIs. Basically, it's nothing but it's an operating system along with the additional software installed upon it. So these are the quick start AMIs. We have Amazon Linux, Mac OS Catalina, Big Sur, Mojave, Red Hat Enterprise Linux, Ubuntu, Microsoft Windows, Deep Learning AMI, Debian, Microsoft Windows Server 2019, 2022, base as well, Data Center Edition. Yeah, so you can see that there are different AMIs you can choose from. This is purely for the demonstration purpose. Now, the one that will be using the most in your business environment is your My AMIs. Now, what are these things? Now, these are the pre-built, these are the custom-built AMIs that you can start using on the fly. Now, as we have seen the customized policy, the same goes with the customized AMI. See, the quick start AMIs, these are the raw AMIs. These are not being customized based on a specific requirement. So this will have the operating system plus set of services and applications of your choice. So in a business environment, you will have a complete container. This is a container only. This is a repository where you can maintain multiple Amazon machine images. Those are customized in nature. Okay, I'll show you that process later on. Marketplace means that you can purchase the services or software as a service from different vendors in the form of AMIs. Okay, this is also that your company will be using a lot. For example, you want to deploy a Juniper VSRX next generation firewall in this infrastructure that's being developed by Juniper Networks. It's a very popular firewall company like Palo Alto, Cisco. Okay, click on VSRX next generation firewall, and immediately you will get the prompt to deploy this firewall by using the AMI. Okay, so it's a VSRX next generation firewall. You can see the product details of it, the pricing details. Now it's available for free for 30 days. Okay, and you can see that there's a software fee imposed upon you, 55 cents per hour. This software fee will go to the software vendor, that's Juniper. The instance fee per hour will go to AWS. You don't have to go to them separately and pay to them. Just pay them an hourly fee, and then based upon this amount, it will be distributed to Juniper and AWS. Now you can see this is, instance type on the left-hand side. Instance type is nothing but it's the physical specification of those instances, the amount of RAM, the CPU, the storage, and instance offers to you. Okay, now the higher you go, the more you have to pay. So you can see that the instance fee will increase as you go down, right? Because the amount of RAM, CPUs will change or increase, but the software fee remains the same. So you can leverage a software from a very esteemed vendor like Microsoft, SAP, Xent, Cisco, Microsoft, and use this software as a service and deploy the services in Amazon's infrastructure by using their AMIs. You have to pay for them. You can also go with long-term. There's an option to go for long-term as well if you want, and also separate charges for storage. Fine. Community AMIs, it is used for lab purpose. Basically, the people who are just experimenting with the stuff, they can publish their own customized AMI in this community repository, and you can use it. It's just for the use for the experimentation purpose or the lab purpose. In the business environment, you'll be using my AMIs and the AWS marketplace the most. Okay, community AMIs, most of them are free, but some are paid. See, if I go with any of these AMIs, I can publish them on community platform, and I have the option to charge for that, right? I can select any one of them, and I can make it public in nature. These are private as of now. If I make them public, they will show up in community AMIs. I have the option to include a charge on them, but you will see that 95% of them are free of cost. Just 5% are paid. Okay, these are free. Okay, so coming back to the quick start. So the quick start AMIs are the one that you use for the demonstration purpose. And of course, we're just doing the demonstration stuff. Then we're using this right now. Now you will see that we have the Amazon Linux 2 AMI. It is one of the basic AMIs you can start using on the fly without giving it a much thought. Okay. I click on select, and you will see that it's being selected. Now, the next type is that you have to choose instance type. Now, I don't want to deep dive into different instance types as of now because it's a complete theory. But I want to give you a very basic information before we go into the advanced concepts later on. See, for example, today you just want to simplify the things. Today you want to buy a laptop. Maybe you say, okay, I want to buy a MacBook. Okay. Now, based upon your budget and your requirement, you will see that, okay, what's the amount of storage it gives? Maybe you want to go for 512 gig of SSD storage. What is the amount of GPUs it has? The RAM specifications. Maybe you want to go for a 64 gig RAM. Okay. So depending upon your requirement and budget, you choose the specifications of your laptop or the computer that you want to purchase. Similarly, in a business environment, if you want to buy a production server, you see the amount of RAM, storage it offers. Similarly, when you go with a virtual machine, you will see the amount of virtual resources it offers to you. Now, the virtual resources is in the form of virtual CPUs. Okay, now I don't go into a lot of specifications. It is one virtual CPU. It says 2.5 gigahertz of Xeon processor, 1 gig of RAM, right? Some amount of storage. It gives you almost 8 GB of storage, right? So this is the T2.micro, which is a free tier eligible. Now, one thing that you have to understand, if you're using a free tier account, make sure you use a T2.micro or T3.micro instance type, depending upon the availability. So if you're using a free account and you want to refrain yourself from paying extra charges, of course, no, who will do that unless it's required. If you don't have much of the requirements and you want to go simple, then go with T2.micro. Now, these instance types are being differentiated in form of different instance classes. For example, T2 are the burstable, which means that you can also add some credits to them. You can increase their performance afterwards. We'll come to that afterwards. So the thing is that these, based on your requirement, these are instance families that based upon different requirements. For example, this C type instance type, they give you more compute capabilities. Then we also have, for example, G, that stands for G will give you more GPUs, the graphical processing units. Then we have, for example, M4. These are used for web-based applications or very medium-built database applications for a variety of use cases. Okay. We also have R, which gives you a lot of, so anything which stands for R in the instance family will give you more amount of RAM. So the thing is that you can see on the right-hand side, the virtual CPU, the amount of RAM this gives to you, and based upon that, they will charge you. So, right. So it's like you're going to a store, and the more RAM you add to a laptop and the more the high performing resources you add to it, the RAM configuration, the GPUs, the storage, the more you have to pay. It's the same thing. Now, it all depends upon the workloads you'll be running, the set of services and applications you'll be running upon these instances. Fine. So now the next thing that you will see over here is, now the very first thing is that you need to define the number of instances that you want to deploy in one single shot. Now you can go up to 10, 100, 150, depending upon how many instances you can launch in one single shot based on your account. And for example, I want to deploy 10 instances with the same configuration, same instance type, same operating system, same settings, right? But I'll just go with one. There's another option which says launch into auto scaling group. Now, what's that? Now, auto scaling group is just to facilitate automation process. It's there to facilitate your automation process. Purchasing option. Now, the thing is that whenever in a business environment, you want to deploy an instance or a virtual machine, there's some billing options that you are being presented with. Apart from this instance type you choose, you also need to pay for that how you'll be running that instance. Maybe based on the time, hour consumption or the seconds consumed, or maybe you want to reserve it for a 1 year or 3 year contract. Okay. Now, if you search on their documentation, if you just Google it, just AWS EC2 purchasing options, if you just type these keywords, so you'll be able to see that how they are priced, they are different. So what is their different billing options they have? I just put the link in the category. It's not there on the slide itself. So how they will charge you for the running of instances. Apart from these types that you choose and you have to pay for the specifications, based on the consumption-based model, you need to pay for these different types of these instances based on the pricing model that you choose. Now, on demand is the one that is very common to use because it can be used in any account, whether it's a demo account or it's a business account. On demand means that there's no long-term commitment with Amazon Web Services, no long-term commitment with them. There's no upfront payment. You don't have to pay anything at the initial stage. You deploy any instance, you use it for a few hours or seconds. If you don't need them, stop them. That's it. You pay for the time consumed. And that's it. It's like you hire Uber to drive to a destination. You just pay for the amount of miles or kilometers you have traveled, and that's it. You don't have to pay Uber driver the payment for his installment for his car, right? So it's based on the consumption, the number of hours consumed. Once you stop using those your instances, that's it. your commitment stops. You pay for the time consumed, and that's it. There's no long-term relationship or contract with Amazon. Now, this goes a little bit costly in terms of usage. If you have any usage which is low cost usage and flexibility, start using it. It is used for a very short-term basis, spiky and unpredictable workloads. So for example, you're getting your feet wet and you're still trying the waters. You're just trying to test the things out before you can jump in and start going big on AWS. At the initial stage, for example, for the first few months, you say that, okay, let's test the things, let's test the waters and see that whether it suits us or not. I've seen from my experience that people go to AWS, sometimes they might go to then Azure or vice versa, right? The biggest benefit about these cloud service providers is that they give you flexibility to come in and go out. They don't want to bind you, right? You come in, use the things. If you like it, go for a long term and save your cost. If you don't like it, exit. You can still stick to your on-premises network or go to Azure or GCP. Okay, if you don't like Uber, hire Ola, right? Or hire Lyft. So you can switch back and forth between different service providers. Now, if you think that, okay, for example, I need to go for a 1 year or 3 year contract. In that case, you go with reserved instances. Now, reserved means that you come into a 1 year or 3 year contract with Amazon. It gives you up to 72% discount compared to on-demand pricing. Okay, so for example, an on-demand instance costs you $1 a minute. Then you have to pay, for example, just 30 seconds a minute. I'll just give a rough example. So you can get up to 72% discount compared to on-demand. You come into a 1 year or 3 year contract with AWS, you purchase these reserved instances. So now this benefits both the parties. Amazons get a long-term contract with you. They get an upfront amount. Now you can pay upfront amount in 3 different phases, installments. It's up to you. So Amazon know that, okay, this customer has come to us, has given us a good amount upfront. Let's give him the benefit, and you get the benefit in terms of discounts. Okay, now you can see over here, if you just go to, let me just go back to this instance page, you can see that we have the reserved instances. Now, reserved instances, you can, for example, just go to this page and click on purchase reserved instances. You choose a configuration, choose the term, 1 year or 3 year contract. You choose that, and you can start using. Once you pay the upfront amount, they have some flexi options to pay to make the payments. For example, no upfront, partial upfront, all upfront. It is different payment options that they give to you. Either you pay in installments or you pay your entire thing upfront, and you can purchase it and get a huge discount. Now, in a business environment, you'll be using a lot, right? So you can choose the platform, choose the instance type, then classes. You can convert them in future or just keep them as standard. Payment option, flexi options, how you'll be paying for that. For example, I'll be paying half amount right now, half amount after a few months, or maybe I want to pay the entire amount right now. And that's it. So once you launch the instance with the same specification, it will be charged under the reserved instance category. And it's nothing but it's the discount applied on your on-demand usage, right? The next thing that you'll be going for would be, now these are the 2 that you'll be using the most. Spot, I don't think you'll be using it. Basically, you bid for unused EC2 instances. Few companies use it. For example, Netflix uses it. Basically, you can use it temporarily for processing some information or just for the demonstration purpose. Basically, you do the bidding. There's a spare capacity. Now, the thing is that there's a problem with the spot instances. They can be terminated anytime. You can lose access to them anytime. Yes, you can get a buffer time, but they are not used in all the use cases. I don't think you'll be using a lot in a business environment. The next is the savings plan. It is kind of reserved instances with a lot of flexibility in terms of whether you want to go for hour usage, 1 year usage, 3 year usage. It is a kind of reserved instances, but gives you a lot of flexibility in terms of the configuration that you get. Now, dedicated host is nothing but it's a dedicated physical server that you get for your usage, a complete physical server. Okay, so you can purchase a physical server. They will allot you a physical server. Now they will charge you on the on-demand basis, or you can reserve that physical server and you get that physical server upon which you're the only one to deploy your virtual machines upon. Okay, you get the entire physical server. See, this is a complete physical server that you can use upon which you can deploy your EC2 instances. If you see from the hardware perspective, you get the dedicated host. Per second billing, now basically you also being billed for per second usage if you're using Amazon Linux, Windows, and Ubuntu operating system. Okay, so if you, for example, if you stop the instance, if you're running an on-demand instance and you stop it before 1 hour completion, they will charge you for the number of seconds consumed. This was a very concern from a lot of consumers because, so for example, if you just run the instance for 20 minutes, you'll be charged for the complete 1 hour. So now they've come up with this option. Okay, you run the on-demand instance. Okay, so these are some of the purchasing options. Whenever you get the free time, go through them. Okay, it's complete theory, but from my experience perspective, you'll be using on-demand and reserved instances the most in your business environment. Okay, now next we will discuss the VPC. Okay, now VPC or the network is nothing but it's a virtual data center that you deploy in the cloud. Okay, now there's a very separate concept on VPC in detail that we discuss, but I'll brief you about it. See, what is a VPC? See, what happens over here is that let's imagine that today your company says, okay, you work with a company and they today decide, okay, let's go and start deploying our resources on AWS. Let's do that. Now, a lot of companies have this challenge or they have this concern about security because even their competitors are on AWS and you, me, anyone can sign up with AWS and start deploying our resources on the fly. We need some privacy. We need some isolation from other people because let's suppose Vodafone, Microsoft, Airtel, Zolosoft, multiple companies are working, multiple companies have their accounts on AWS. They have their infrastructure running upon the same platform. Now, how you can protect the unwanted or unauthorized access from them? You want some privacy, you want some isolation. So they have come up with this concept. For example, the concept is called VPC, that stands for Virtual Private Cloud, right? So we have this. Okay, now what happens in this VPC is that you get the entire data center with you. So what they say is that VPC is this is a kind of a virtual data center. And it gives you flexibility in terms of resource management, and it gives you security. Now, how it is secure? I just give you one simple example. Let's imagine that this is a VPC which is owned by Vodafone. It is owned by AWS, but there's a separate VPC owned by Vodafone. Now, there's a separate VPC owned by Airtel. Now, even though they're competitors, they are on, for example, on Amazon's platform, fine. So they have their individual infrastructures on AWS, but they're kept separate. So it's a kind of, we can say that it's a virtual data center. So they will say, okay, the Airtel's network is different from Vodafone's network. They are on AWS, but they're being kept separate. They are being given the isolation. They're being isolated from each other. Even though they're running their infrastructures on AWS, they are being kept separate. For example, let's imagine you go to a hotel, your room is different and the other customer's room is different, right? Similarly, you are using the same premises, but you are being kept separate, fine? So that there's no, so you get the seclusion or the isolation, fine? So it's a kind of a virtual data center. Now, what happens in a VPC is that if I just get into some more details, VPC is a region-specific resource. For example, this is my VPC, right? This VPC is in Mumbai. Now Mumbai is denoted by this terminology or this term AP South 1. Fine. So AP South 1 is my Mumbai region. Now, so what is a VPC? It's a virtual data center. Now in a VPC, we have different subnets. So VPC is given us an IP address range. For example, it is 10.0.0.0/16. Okay, I'm just giving one example. And this VPC will have the subnet. For example, this is subnet. Now subnet is a complete block of IPs. For example, so would be linked to AP South 1A and will have a set of IPs assigned to it. For example, 10.0.1.0/24, right? It's a complete block of how many IPs? 4091 IPs. So this is a set of somewhere around 4000, I think 91 IPs. Right? So these many instances can be launched into that. So a subnet is a block of IPs which is linked to one of the data centers or availability zones, and you deploy your instances or databases inside them. So these are your EC2 instances, right? Similarly, you can have a different subnet. So a subnet is nothing but it's a block of IPs. It's there embedded into a VPC, which consists of your instances. Fine. So a subnet is nothing but it's a block of IPs. A subnet is linked to a specific data center or the availability zone in that region. You can have different subnets in a single VPC. Fine. So VPC is nothing but it's a virtual data center, which gives you flexibility and the amount of security that you need to go for. Okay. Now I just go ahead and show you the stuff. Now this is the VPC. This is the default VPC. This is there by default. These are different subnets which are linked to different availability zones in North Virginia, because the dashboard I'm working on is the Virginia's one. Fine. So for example, I choose this subnet. In this case, the instance that I'm going to launch would be deployed in used East 1D availability zone. But I choose to no preference, then Amazon will automatically pick any one of these different subnets or availability zones and deploy my instance into that. Fine. Now what happens is that your instance will get the private IP address from the IP address range assigned to the subnet. So the private IP would be fetched from the subnet range, right? So instance will get the private IP from those 4091 IPs. So private IP is used for internal communication, which means that communication within the VPC. So it's used for internal communication. So if two instances in a VPC want to communicate with each other, what they're going to be using? The private IP. Now, what if this VPC needs to communicate with the internet? The instance within that needs to communicate with the internet, then you can auto assign the public IP, so that apart from the internal communication, this instance can be public in nature and can talk to the internet. For example, if you deploy any website or web application for this instance, it can use the public IP. Fine. Placement group. Basically, placement group is nothing but you cluster your instances. For example, you go with a cluster placement group. Now, this is the one that you'll be using the most. Okay. Placement group means that you cluster the instances together in a single data center so that they can talk to each other with minimal latency. If you have instances running in a single availability zone, they will have the fastest access to them because they're running in the same facility. You can cluster them together. Now, you may have this requirement where the instances need to have an internal dialogue with each other for a fast performance. In that case, you can cluster them in a placement group. Capacity reservation is one concept where you can keep this capacity reserved for a few hours. For example, you need to deploy 100 instances. You need to have this capacity guaranteed for a certain amount of time. Okay. Frankly speaking, I haven't seen this being used in any production environment. You have this option. You can create a new capacity reservation by ID, or you can just create a new capacity reservation. For example, let me show you. I click on create new capacity reservation. So I can see that, okay, I want to reserve 100 instances for few hours, right? So this would guarantee you the reservation for a specific duration. See, sometimes in few situations, you're going for on-demand instances. Even the on-demand instances are not available every time. For example, you're going for a very specific high-level configuration. And sometime that specific instance, the type that you want to go for, you need 100 instances of that. Sometimes those 100 instances might not be available at that time. So if you want to guarantee it for a certain duration, for example, specific time, then in that case, you can specify that date and you can reserve that capacity. Fine. Frankly speaking, I haven't seen that used too much in a business production environment, because either the companies go with on-demand, or most specifically, they'll go with the reserved. Okay. So this guarantees you that you'll be guaranteed the capacity for a certain duration. You can choose that, okay, I want, this is the instance type, this is the platform, this is the availability zone. Just give me, I can end my reservation whenever I want. So guarantee me the capacity until I cancel it out. So every time you launch those 100 instances, or out of 100, you pick 20 instances today, 20 instances tomorrow, you will get up to 100 instances guaranteed. There's a cost for it. Fine. Okay. Having said that, let's go back to this page. Domain join directory. Now you can have a domain created and join this thing with your instance, but as of now, it's not needed. IAM role I've discussed with you. So you can use this role so that this instance can access my buckets in my account. Shutdown behavior. When you shut down the instance, do you want to stop it or terminate it? Stop means that you can stop it, start it, stop it, start it, stop it, start it without losing anything. Terminate means that you permanently remove that instance from the account. It's completely gone from your account. It will not be there. So you get rid of the instance itself. You delete it, you permanently remove it from the account. So I just make it stop as the default behavior. You can also enable hibernation as an additional stop behavior. You can also put it to hibernate state, but I will just uncheck it as of now. Enable termination protection. Now, see, when you terminate any instance, maybe this instance that I'm going to deploy is a very high-end production server with a very critical application running upon it. If some IAM user by mistake accidentally terminate this instance, my operation would be inhibited. It would be hampered. So I just want to make sure that no one can accidentally terminate this instance. I protect it from accidental termination. In that case, the termination option gets grayed out and it has to be enabled. There's a series of steps that needs to be followed to re-enable that. So if you want to gray out or you want to disable this termination option for a very critical instance, then you can check this option. Okay. Now, the next thing is the CloudWatch detailed monitoring. Monitor means that why we want to monitor it. We want to monitor the performance of the instance. We want to analyze, we want to gauge upon our instance performance. Now, this begs this question that why an instance performance needs to be gauged. See, an instance will take the traffic, process the information, send back the request, store some information. Now, an instance will have some capacity. If that capacity is being maxed out, the application running upon an instance would be impacted, would be severely impacted or adversely impacted. Now, it's important that you can analyze its behavior, its functionality, so that if it's touching the limit where it can just shut down, or maybe it is impacted or it hangs or freezes, then you can take some appropriate steps beforehand. Now, the monitoring is done by a single service that's called CloudWatch. Now, CloudWatch is a service that we discuss explicitly in detail in SysOps curriculum. Okay, so now we're talking about the CloudWatch in terms of instance performance. So how it works? So let's imagine that this is my virtual machine. This is my EC2 instance. Now, I want to gauge upon the performance of it. Now, what happens is that you need to imagine the CloudWatch as a separate entity. Now, CloudWatch, we don't run it upon the instance. It is a separate entity. So you don't run upon EC2 instance as a client software. Instead, you treat it as a separate entity. Now, how it will analyze the performance of the instance? That's the main thing that we have to look into. See, what happens is, basically, it analyzes the performance based on the metrics. Metrics are the parameters, or it is a scale based upon which the performance would be analyzed. For example, I'm running a marathon. So how my performance will be analyzed? Based upon the kilometers or the miles I ran in the certain amount of time. Okay. So in a marathon, what are the two metrics? Kilometers or miles to cover the distance, to calculate the distance covered, and the minutes or hours for the time consumed. So what are the metrics? Minutes and kilometers. These are the scales based upon which my performance as a marathon runner would be analyzed. Now, similarly, we have metrics. Every single resource will have its own set of metrics. For example, EC2 instance will have metrics like, let's suppose, CPU utilization. So it will have a lot of metrics, but I'm just giving you one example. CPU utilization. Now, whenever you launch an instance, the instance will push those metrics to the CloudWatch. It will say, hey, CloudWatch, these are the metrics based upon which you'll be gauging upon my performance. It will push those metrics to the CloudWatch. For example, the CPU utilization. Now, the CloudWatch will ping, it will try to get, it will just call the instance, say, hey, instance, I know that what your metrics are. Now, could you please give me the values? So the instance will then push metric plus statistic. So instance will say, okay, this is my performance. For example, presently my CPU usage is somewhere around 70%. It will push that information to the CloudWatch, and you can easily log into the CloudWatch. For example, this is you are the system administrator. You can easily log into the CloudWatch and you can see that, okay, yes, and this is what the performance right now. Right now, the CPU performance is 70%. Okay, so the resource will push the metrics to the CloudWatch. CloudWatch will analyze the performance of the instance. It will fetch the metrics along with the statistics from the instance, and you can log into to the dashboard and you can see the entire picture. You can exactly see that what's going on. Now, the frequency of this monitoring, especially with respect to the instance, it comes in two flavors. There are two types of frequencies. So if I talk about the frequency of monitoring, means that how frequently the monitoring would be done. There are two frequencies. The first frequency is called the standard. Standard is a default frequency. Standard/default. Now, the standard or default frequency, it is a 5-minute interval, which means that it will happen every 5 minutes. So every 5 minutes, you can just get the new fresh statistics, and this is free of cost. So CloudWatch will monitor the performance of the instance every 5 minutes. The dashboard, you can just get the fresh statistics. So every 5 minutes, it will come up with new data. Okay, the real-time data, the present data. So that's the first one. The second frequency is the detailed monitoring. That's a detailed. Now, for mission critical applications, if this is a very critical instance for you, you can say that, okay, I'll monitor its performance very extensively, and I can go with detailed. Now, what happens in detailed is that you lessen down the frequency. So you bring the frequency down. Every time it will ping the instance every 1 minute and give you the fresh statistics. But so it is fast in nature. So it's a 1 minute frequency, but it's paid. So every 1 minute, it will ping the instance and get you the fresh statistics. So it is a 1 minute interval. Fine. Monitoring. So these are the two different flavors of the CloudWatch monitoring with respect to the instance, standard/default, and then we have the detailed monitoring.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Now, I'll just go back to this thing. So if I keep this option checked, it would be standard. If unchecked, it would be standard. The 500 frequency. If I check it, it becomes detailed. So if I uncheck it, what happens? It becomes standard monitoring. It remains standard with a 500 interval frequency, which is free of cost. But if I check it, it becomes detailed, which means that the performance will be monitored every single minute, but it's a paid option. The additional charges apply. Okay. Now, the next thing is tenancy. Tenancy means that how exactly what's the platform that you're using to deploy instance upon to. One is shared. See, your instance will run on a physical server. This is a diagram that I want to show you over here. So if you see this diagram on the right hand side, let me see if I can just click on that. Okay. If you see this diagram right now, what happens is that you have a physical server, a bare metal, and it's a host server. What you do is that you install a client software that's called hypervisor. Hypervisor is a layer. It's a client software that you install upon the bare metal, and it will help to deploy different virtual machines with different guest operating systems. For example, guest 1 is a virtual machine which is supporting Windows Server 2016. Guest 2 is another virtual machine which is supporting Ubuntu Linux machine. Guest N is another virtual machine which is supporting, for example, let's imagine Mac OS Catalina, right? So on a single host server, you deploy a hypervisor. That hypervisor will facilitate deployment of different guest machines, different virtual machines. Now in AWS, those guest machines are the EC2 instances, right? Now the thing is, guest 1, guest 2, guest N, EC2 virtual machine 1, EC2 machine 2, or EC2 machine N. If they belong to different accounts, different customers, different organizations, it is assumed as the shared tenancy model. For example, you hire an apartment, okay, which consists of 5 rooms. Now, you don't need 5 rooms to stay in. You're just the only one. So you say, okay, I'll go to a shared apartment where I'll stay with other people and I'll share the rent, right? So similarly, you just go with a shared tenancy. You're saying that, okay, I'm not the only tenant. I'll share the physical server space with other people. So in shared tenancy, your EC2 instance, your virtual machine will be running upon a physical server, which is being shared by other consumers, by other clients, other organizations, other accounts. Now, this tenancy cost is free. You don't have to pay for this tenancy. But if you say, oh, okay, I don't want anyone to barge into my apartment. I want to have my own space. So guest 1, guest 2, guest N, all the EC2 instances will be yours. You say, hey, AWS, allot me this physical server. I want this physical server. Give me that. I'll be the only one to deploy my instances upon that. So all the guest machines, all the virtual machines would be yours. So in that case, what you can do is that you can just go back to the instance dashboard, and then you will say, okay, if you go with the shared, this is free of cost, where you'll be sharing your instance with share the physical server with other clients, with other account holders. But if you go with dedicated instance or dedicated host, the same thing. Dedicated host is much advanced. If you go with dedicated, then you are given a private space, a physical server you own, and any instance that you deploy in the future will be deployed on a dedicated physical server for your usage. But for that, you have to pay separate charges. Now, this begs this question that, okay, why would I go for that? Why would I pay separate charges? See, might be you have some compliance requirements where you're not allowed to deploy instance on a same physical server upon which the virtual machines of other people, other account holders are running. You may have some compliance requirements. You may have some security and compliance issues. Even though you get the isolation and segregation at the shared instance level, still your company's policies don't allow you to have a shared virtual machine on a shared physical server. You have some strict legal, security, and compliance requirements. Sometimes there's some software requirements. For example, the Oracle Enterprise databases, if you want to deploy that on AWS, you have to go with the dedicated database instances. Some software requirements may force you to go with the shared dedicated instances. So some software, legal, compliance requirements may push you towards dedicated instances and pay you some extra bit of amount to get some private space at the hardware level. Okay, so I go with the shared tenancy as if now. So that's about the instance details. I've discussed with you pretty much a lot of options so far. Let's click on next add storage. Click on next add storage. Now, this is the amount of storage being allotted to the instance. This storage is called the EBS volume. Now, this is kind of a virtual hard disk you assign to the virtual machine. That's your EC2 instance. See, you're using a laptop or a desktop to join this session, to be a part of this session. Your laptop or a desktop, whichever machine you're using, maybe a tablet, it has some internal storage. If you don't have the storage, it will not have any space to boot the operating system upon or to store some data, to have the system files upon it. So a virtual machine needs a virtual storage. That virtual storage, that a default option is called the EBS volume. Now, by default for Linux machine, you get 8 GB of root volume. Now you can change the storage up to 16 terabytes. Click on exact tags. Now tags is nothing but it's a simple identifier just for the documentation purpose. See, you will have a dashboard. Now, for example, you have the S3 buckets, right? If you have multiple S3 buckets, you can identify those buckets. Okay, this is the bucket for my production environment. This bucket is for the development. This bucket is for this team. This bucket is for this business unit. Now you have the names allotted to the buckets. Similarly, you assign some special names to the instance just for the identifying purpose. Maybe you're running 1,000 instances on a page and you assign special names to them. Okay. So for example, I add a key first. Key is name. And I just type the value for this one. For example, production server. This is for a team. For example, this team is anything production server, team, or project alpha. Right? There's a separate team. There's a separate production server in that team, and this instance belongs to them. So you can identify that on a single page. You can identify that instance. Okay, this instance is meant for this one, just for the documentation purpose. Okay, click on next, configure security group. Now this is very important. See, a security group is nothing but it's a firewall that you apply to your instance to restrict the incoming and the outgoing traffic, or you specify that which is the specific traffic to reach your instance. So for example, you allow a web server access and you want to restrict the incoming traffic or outgoing traffic with respect to that instance. You want to restrict the traffic. You don't want the traffic to just any traffic to reach your instance. Now you need to have some kind of restrictions imposed upon the instances. So what happens in that case is that you want to ensure that you can filter the incoming and outgoing traffic with respect to your instances. So how exactly you can do that? Right? Okay. So what is a security group? Let's imagine that this is my AWS cloud infrastructure. This is my Linux instance. So this is my Linux EC2 instance. Now, upon this Linux EC2 instance, I have, for example, a WordPress blog running. A WordPress site. Fine. Now, the thing is that there are two different set of people who will be accessing this instance, one for the administration purpose, another one just to access the website upon it. So on the right hand side, I have this data center located. So this is my on-premises network. This is my, for example, my corporate network. This is my in-house data center. So this is my corporate network, and this is my in-house data center or office. Now, this is where my solutions architects, my administrators will be operating their day-to-day task. Now, this office will have a specific IP address assigned to it. Okay. Now, I can say that, okay, if my internal employees, the IAM users I'm talking about, IAM users, they will be accessing this instance they will be getting the root access to the server to, for example, install some scripts, some software, some additional services, right? So they need to get root access. Now, if it's a Linux instance, we'll be using SSH. SSH opens the access to the root of the Linux server. It uses port 22. Now you allow it from this IP. Now, if it's a Windows, you'll be using RDP, but we are using Linux for this thing. So I'm saying SSH is allowed from the known IP address, from my branch office IP address. On the other hand, I have a bunch of external users. External means these are the internet users. These are the internet / external users. Fine. Now, these people need access to my instance so that they can access this application. Right. So the thing is, what they will be doing is that they'll be sending the HTTP request, which uses port 80. Maybe they're sending HTTPS traffic, which uses port 43, right, to access the web application running upon the instance. Now, I will give them to open access to my web application. So I'll say, let's allow the HTTP access or HTTPS access from anywhere. Anywhere means 0.0.0.0/0. So I'm saying, okay, allow the HTTP and HTTPS access, the web app access from anywhere, but the access to the shell of the server, the core of the server, has been given to the people in my branch office who can perform the day-to-day server administration. Now, who performs this job? This job is performed by security group. Now, you segregate the traffic, you filter the traffic based upon three things. You filter the traffic based on first port, protocols, and IP addresses. These are three filters that you use: ports, protocols, and IP addresses, based upon which you can restrict the incoming and even the outgoing traffic. But generally, you mainly focus on the incoming traffic. So a security group is nothing but it's a firewall. Now you use that firewall to restrict the incoming traffic. See, mainly the incoming, but you can also do the outgoing. Okay. I'll create a new one. I'll name it as, for example, production Linux or production WordPress server. SG stands for security group. Just copy and paste the same in the description. Fine. So set a name to it and a description. Now the SSH is allowed either from my IP. Now this automatically picks the IP address of my computer I'm working on right now, or I choose a custom IP and as I say, okay, 56.0.0.0/16. Now this is the, so I'm saying I want to allow access, allow root access to my in-house sysadmins. So my in-house system administrators will get the root access to this thing. So this belongs to my branch office, my in-house data center. And on the other hand, if I deploy a WordPress site upon it, I would choose anywhere. The users can get the web access to the WordPress site running upon the instance. So I'm saying HTTP access from internet users, they can browse the website running upon that. I'm not giving them the root access. Root access is with the in-house people, but the website access is with the external users. See, for example, right now we are accessing the Intellipaat's website. Fine. So the thing is that Intellipaat's website is maybe running on a virtual machine behind the scenes. I'm not getting the root access to it. I can access the website. Fine. Click on review and launch. Now I can review any of these parameters before I can hit launch. Click on launch. Now this is a method of authentication to get a secure access to your instance. This concept is called key pair. One key is with AWS embedded into the AMI, and the other one is that we store on a computer. So I'll show you that afterward how you use it. I create a new key pair and assign a name to it. For example, name it as prod-kp. Now it will store a PEM key that I'll be using to authenticate and get a secure access to the server. Click on download key pair and click on launch instances, and that launches our instance. Plain and simple concept. Okay, I have requested more virtual CPU capacity. I chose 100 because I'm using business account, not an enterprise account. That's the reason. So over here, I can click on launch and simply launch my instance. So I just launched the instance real quick. Now, whenever you choose the AMI, then the next thing is that you have to choose the instance type. Now, as I've already discussed with you, an instance type is nothing but it's the virtual representation of the underlying physical resources. So the amount of RAM, CPU, storage, GPUs, the amount of resources that an instance type offers to you, based upon that, you can deploy your set of services and applications upon the instance, and you can change it afterwards. So if you don't have the idea that, okay, which instance type is the best for you as at this position, you can always go back, stop the instance, and you get the option to change it afterwards. I'll show you. So you can change the instance type. Now, there are different instance families. So some are compute optimized, which gives you more compute power. Some are storage optimized, which gives you more storage. Some are memory optimized, which gives you more RAM. So based upon that, they have differentiated in as per different instance categories or instance families. Now, if you're using a free account, either go with T2.micro or just go with T3.micro. Okay. Now I just click on next configure instance details. I discuss with you a few of the options in detail, including the purchasing options. Now, as if now this instance that I'm installing or I'm launching would be the on-demand instance. So we discuss on-demand instance, which is the purely time-based, consumption-based model. You pay for the number of seconds or hours consumed. Then we have reserved instances, where you reserve those instances for 1 year or 3-year contract and get a discount of up to 70% compared to on-demand. Then we have, for example, we also discussed the dedicated host, dedicated instances where you can deploy the instances on a dedicated physical server, spot instances, which is rarely used in a business environment, where you bid for unused compute capacity. But the thing is that the instances can be terminated at any given point of time. So basically, you will use on-demand or reserved. Network, I discussed with you the VPC. VPC is a virtual data center. Now, within a virtual data center, you have different subnets. A subnet is a complete block of IPs, the private IPs, and each of these subnets is linked to a specific availability zone. Now, as per the AWS best practices or recommendation, as per the best practices and recommendation, it is always recommended that you choose no preference, because in that case, AWS will ensure that they will have your instance being deployed in a availability zone which has enough capacity, because might be I'll be launching 100 instances in one single shot. So sometimes if I choose a specific availability zone, that availability zone, it may not have enough capacity to support that specific instance configuration. So you choose it to no preference, just to make sure that your instance can be launched in any availability zone which has enough capacity to support the number of instances that you need. Then you can auto send the public IP, which exposes the instance to the public. Placement group I've discussed in brief. We'll discuss in detail afterwards. You can go with a cluster placement group where you intentionally cluster your instances together so that they can have a faster access towards each other over a high throughput network and high throughput and low latency network. We will not discuss it as of now. Capacity reservation is just to guarantee you capacity for a specified duration. Domain join we will not discuss right now because generally you may or not or go with this. I will not discuss this thing. We skip it. IAM role, as I've discussed with you, this facilitates this instance to access some other resources on your behalf. So I can have this instance access these 3 buckets. Shutdown behavior is stop or terminate. Stop means that you stop it, start it. Terminate means that you permanently remove it from the account. You can enable this protection against accidental termination so that no one can by mistake terminate this instance. I discussed with you different 2 flavors of CloudWatch. One is standard monitoring, the frequency of which is 5 minutes. The detailed monitoring, the frequency of which is a minute. Standard is free of cost, detail is paid. Tenancy I've discussed with you, shared and dedicated. Shared means that you run your instance on a physical server upon which the instances of other account holders would be up and running. If you go with dedicated, because if you have some security compliance requirements or software requirements, then you being allotted a complete physical server, only your instances would be up and running upon that. Okay. Elastic inference, credit specification, they are not of very importance. Very new options. Still, I have seen that I haven't seen them being used anywhere. File system we'll discuss afterwards. Once we discuss the elastic file system, we can link this instance with a EFS block or the storage that we'll discuss afterwards. Advanced details, we can put a script over here under user data that I will show you today itself after we are through with this topic. Then we can add the EBS volume. Click on XAD tags. We can add a tag to it. Security group, I discussed with you that it's a firewall that is you can use to restrict the incoming and the outgoing traffic with respect to the instance, right? So I also showed a scenario, just a real recapitulation, just to make sure that we do the revision before we can jump to the next level or the advanced concepts, right? So we discussed this thing, security groups. Now, why security groups are important? Because it's a firewall that you apply to the instance or the instances. You can restrict the incoming and the outgoing traffic with respect to the instances. For example, in this scenario, I allow the SSH traffic from the known IP addresses from my data center or my in-house office, but the web access is given to the external users. It ensures that only the authorized access is given to a bunch of users, right? So it is a firewall which restricts the incoming and the outgoing traffic with respect to the instances, and you filter the traffic based on 3 different parameters: ports, protocols, and IP addresses, right? Now, you may be a developer coming from a development background. This may be a bit off the track for you, but that's the only thing that you have to understand, right? You don't have to go into very advanced firewall configuration. It's a very basic thing. Just try to memorize the concepts, okay? Click on review and launch. You can review the parameters, click on launch. Now you can create a new key pair or choose an existing one. Now this key pair will be used to authenticate and get access to the instance afterwards, fine? And then you can launch your instance. So this is what we have discussed while launching the instance. Let's move forward with the connection process, right? Okay, so guys, the thing is that we need to understand the process of connecting to the instance, and it's a very easy process. It is just that you have to understand that how exactly this works for you. So the thing is that from your local machine, you'll be getting access to this instance running in the Amazon Web Services cloud infrastructure. See, the thing is that you connect to this instance from your end, and the process is a bit different whether you're connecting from a Linux machine, a Mac machine, and the Windows machine. Now, the thing is that this is a Linux instance, right? Now it uses the SSH protocol over port 22. Now, the thing is that AWS has given you multiple options out there. For example, you choose the instance, click on connect, and you have this EC2 Instance Connect. Now, this is a new option out there, but this is not very reliable. I don't think that you'll be using this in your business environment a lot, because it is browser dependent, and sometimes your browser may not support it or not. Now on Safari, it doesn't work properly. Sometimes it works, sometimes it does not. But on Chrome, it works perfectly fine. So I can go to EC2 Instance Connect. Okay, before that, I need to make sure that I just go to the security group of the instance, and I can just refresh the SSH coming from my IP, because in that case, I'll be making sure that I'm authorized to gain the root access, the SSH access. Yeah, so I just use my IP so that it picks the computer, the IP address of my computer, and I can get access to this instance. Now, the thing is, you need to make sure that once you allow the SSH from a known IP address, then you can just choose the instance, and you can click on connect on the top. It shows you EC2 Instance Connect. This is the default username. So EC2-user is the default username of the Amazon Linux instance AMI. The public IP address, instance ID, you click on connect, and if your browser supports it, then you'll be able to connect to the instance without any issues. Now, sometimes it works on Safari, sometimes it does not. Yeah, this happens sometimes, but I think on Chrome it will work fine. But what I'm saying is that the most stable connectivity option that you have is the client software, Putty. You might have used it, might have heard about it. So you need to depend upon some third-party client softwares if you're using Windows, right? So if you're using Windows as your base operating system, a Windows machine, then you can install Putty or any third-party client software where you put all the information and you gain access from that. It's a very stable connectivity option that you get instead of going for any browser-dependent connectivity options, right? Okay, so I have a Windows machine running. Let me just drag and drop it over here. This is Windows 10. I think Windows 11 has now been introduced. So I'll get license copied after, but this is an unlicensed copy because I'm just using that for the demonstration purpose. What I will do is I'll show from the Mac first. I'll be using it to connect to the AWS account, to the AWS instance running in the Amazon's infrastructure. Now you can download Putty for free of cost. It's not a big deal. If you just Google it and just type in Putty free download, you will get a ton of resources out there to download Putty free of cost. So let me just put that. And I'll see that if I show you the link over here. So this is a link. Now there are two softwares that you need to install on your Windows machine. One is Putty, Putty.exe. This is the one. So one is the Putty.exe. I'll be using 64-bit version of this thing, Putty.exe. And the next thing that you have to install is PuttyGen. Putty is used to connect, and PuttyGen is used to. Let me do one thing. Okay, if you're using a PEM key, then PuttyGen will be converting that key from PEM to PPK. Whenever you generate a key, let me show you that. So I also download PuttyGen. Okay, now they're being installed on my computer. Hang on one second over here. Now, one thing you have to understand, that whenever you generate any new key, let me show you. See, the key that that's installed on my computer, it's in PEM format. Can you see that? It's PEM, PEM, this one, PEM format. Now, Putty doesn't accept PEM key. It accepts the PPK key, right? Now, why? So you can convert this format. And I think AWS also gives you now the option to download the PPK version of it. Let me see that, if I can get that. So if you generate the key itself, I go to the keys on the left-hand side. If I just try to, okay, if I create a new key pair, can you see that I can also generate a PPK key? Now, but the thing is that originally I went for PEM key. That's okay. If you have the PEM key, use PuttyGen to convert it. Else, when you create a new key for Linux, make sure that you choose PPK and download the key in the PPK format. Okay. So what I will do next is that I'll open PuttyGen. Now, if you already have the PPK key, you can skip this step because Putty accepts only the PPK format. But I have PEM format. I forgot to install the PBK format of it. So I'll convert the key from PEM to PBK. So let me see that because I don't have the PBK version of it. So I have the PEM version of it. Let me see that. But I don't have the, just go to the downloads. Yeah, I have the PEM version, right? So I'll be using the PPK version. So I'll just convert it. What I will do is that, see, there are multiple softwares in the market. You can try any one of those, fine. Okay, so what I will do is that I just go to Putty key generator, go to file, load private key, and load the PEM key saved on my desktop, right? Click on open, and once it imports the key, then I click on save private key, click on save, and this will save it in the PPK format. Now, if you somehow skip it to download that in the PPK format, then you can convert it using the Putty gen. Okay, so I've already converted it. Now you can see that this is the new key in PPK format. I'll be using Putty to connect while using this key. So how will I go about doing that? I go to Putty. Now, guys, in your organization, this is how you will do that, because you're not to be depending upon the browser-related software clients, because sometimes you don't have JavaScript working properly, or the browser doesn't support that. This is the most reliable option. Now, I've used Putty extensively in my day-to-day organization environment, so I'm comfortable using it. If you're using some other software, that's okay. Okay. Now, the very first thing it will ask me is for the host name or the IP address. So the thing is, I need to put in the host name or the IP address. Okay. So how will I go about doing it? I need to just go back. Either I just copy and paste the public IP address of the instance, or the public IPv4 DNS name. Okay, fine. I can put the IP address of the machine. The port will be 22. Connection type, the SSH. Now on the left hand side, you can see there are different categories out there. Now I need to upload the key right now. To do that, I go to SSH, AUTH, expand AUTH. Now the thing is, you just go to this thing SSH. I think they have changed some options over there under AUTH. Okay, yeah, go to SSH and AUTH. Then you can browse the key from here. Browse the PPK key. This is the PPK key that we just generated, and we click on open. And I accept it, and it gives me the login as stuff. The prompt, type in the username, EC2-user, and I shall be able to connect to the instance without any issues. So you need to depend upon Putty or any third client party software in a business environment to get access to the Linux instances from Windows. Okay, fine. Now for Macintosh, it is a very simple option. You need to just open the terminal out there, and basically you need to go to your location where your key is being saved. Okay, so this is my key. So you need to use the PEM key, right? Use the PEM key. Now the very first thing is that if you're using from Macintosh, not for the Windows people, if you're using the key for the very first time, you have to change the access rights of it. So type in chmod 400, type the key name, right? Then SSH-I, type the key name, username, EC2-user, @ Now you define the public IP address or the public DNS name of the instance. So I define the public IPv4 address, paste it, and I'm connected, right? So it is easier on Macintosh compared to Putty. You just need to execute 1 or 2 commands, and you should be connected. Fine. That's a process that you need to just go through to connect to your instance, the Linux instance, using a Mac machine or a Windows PC. Now, we don't use private IP because private IP is only used for internal communication. Public means external. See, right now we're external users. We are gaining access to this instance over internet, not internally. You got the point? I'm using internet connectivity, the internet or the WAN network or the internet network to get access to this instance. I'm not doing that internally over VPN. That's the reason we'll be using the public IP. Okay. Now for Windows, the process is a bit different. So for Windows, what you need to do is that I just quickly launch the Windows instance because the options are almost same. So for example, I launch the instance and I pick one of the Microsoft Windows based AMIs. So let's pick the Microsoft Windows Server 2019 base. Okay, click on select. Okay, then we use t.micro, click on next configure instance details. Now the details are same. You don't see any difference out there. Okay, click on next add storage, next add tags. We just name it as, for example, production Windows Server. Production Windows Server, something like that. Just put it anything over here because we're just performing the demonstration, right? And now we just create a new security group because for Windows, if you want to get the root access, you want to get the root access, you need to choose the remote desktop protocol or RDP, which uses port 3389. For Linux, we have SSH over port 22. For Windows, we have remote desktop protocol, which uses port 3389.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ECT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
I choose from my IP so that I'm the only one to get the root access to the Windows instance. So we use RDP, this stands for Remote Desktop Protocol, to get access to the Windows instances. Click on Review and Launch. Now I can choose the same key pair that I've used with the Linux instance. Okay, you can use the same key pair to access the Windows instance and the Linux instance, and click on Launch Instances. Okay, I think I need to go back and make sure I can change the security group, put a new name for it. Right now, once we launch the Windows instance, then I'll show you the process to get connected to it. Now, for the people who are using Macintosh, you need to depend upon a third-party client software. That software is called the Microsoft RDP or Remote Desktop Connection. So if you just go to the App Store, you can easily get it for free. So from people who own Mac, just go to the App Store and just type in Remote Desktop, and you can install the Microsoft Remote Desktop client on your machine. And the process is very simple. You put in the IP address of the machine and password, and you should be able to connect. I'll show you that how you can get the password to get access to your Windows instance. Fine. So Microsoft Remote Desktop is easy to install on your Macintosh. Now for Windows people, there's no need for that because the RDP client is already pre-installed on Windows machine. Okay. So it's taking some time. Windows take a bit longer to boot up. In the meantime, if you have any questions, then you can just put the questions forward. Sudhanshu is saying from one AWS instance to another instance in same VPC, you can use private IP. Absolutely. If it's internal in the AWS, then one instance can have a dialogue with another instance using private IP because it's on the same network. But because we are connecting from the outside network to the AWS instances, then we use public IP. But if two instances in the same VPC or in same Amazon's network, if they want to have an internal dialogue, they will be using the private IP. Okay. So what I'm saying is that public IPs, there's no security threat. If AWS is getting a public IP, there's no security threat. Okay. Let's forget about internet service provider. Let's focus on AWS. If you're deploying your services on AWS, no two instances will get the same public IPs, or the instance will not have the same public IP as a machine outside AWS. Fine. I think this will pacify this entire conversation. The instance will get the unique public IP. It will not be same as a machine in the same network or outside it. Fine. Okay. So there's no threat to security. Okay. Apart from that, even someone gets the public IP or has the same public IP doesn't mean that you will be able to get access to the instance because you have security groups, you have the key pairs. So you have different authentication mechanisms to give the authorization to the authorized people. Okay, right. Okay. Now let's go back to the Windows instance. The thing is how you can make sure that you can just go ahead and get access to the instance running on Windows. I was not talking about the public IP of the instance. I was talking about the public IP of client connecting to it. You were restricting access to the instance to users using a particular public IP. The answer is same. No two clients will have the same public IP. Okay. I'm not sure which service provider does that. No two machines can have the same public IP on the internet. Okay. Okay. Let me just go log into AWS Management Console. And also one thing that the public IP address is once the public IP complete public IPs is leased out to your corporate network, it is static in nature. The public IPs that are being assigned to your corporate network, it is static in nature. It never changes. You will see on a company's network, the machines have the same public IP every time you log in. So the block of IPs assigned to your corporate network, it remains the same. It never changes. Okay. All right. So let me log into the my root account. Okay, so I just go to the EC2 right now, all services, go to EC2. Now to connect from my Windows machine, I'm running this Windows 10. I just simply click on connect from there. And so I choose my Windows instance. I choose my Windows instance and I click on connect. Now I have to generate a password for it. So I can just go to RDP client. I can download a remote desktop file. Now before that, I can just get a password. Now to get a password, I just browse for the PEM key that's being saved on my desktop. Okay, now this is the password. Now you can change this password afterwards at the Windows level. Now I click on download remote desktop file. Now I open the RDP file that's being saved on my computer, click on connect, just put in the password and from my Windows 10 computer. So I should be able to connect to the Microsoft Windows 2019 server, right? So from my Windows 10 machine computer, I should be able to connect to the Microsoft Windows 2019 server. Fine, that's the way. And on the Macintosh, download the third-party software I've shown you, put in the public IP or the public DNS name along with the password, and you should be able to connect. This completes the conversation of the EC2. I've shown you the entire process of connecting to the instances. Fine. Okay. Let's discuss the concept of EBS, the Staff Elastic Block Store. I also show you afterwards how to create an AMI. We'll show you after we discuss the EBS stuff. We'll discuss that. Okay. Okay. One thing that's I missed out is the concept, the differentiation between the public IPs and elastic IPs. Now, the thing is, the public IP, we already see that we need to have the public IP to make the instance public in nature. Now, what do you mean by public in nature? Public means that it is exposed to the internet. You can get access to the instance over the internet, whether you need to connect to it using SSH or RDP, or the simplest use case is that you have installed a WordPress website or some web application upon the instance. And now you need to ensure, hang on one second over here, you need to ensure that you can get access to it. So the purpose behind we discussed the public IP. Now there's no charge for public IP. So public IPs are free of cost. As you see on the slide itself, they're free of cost. Now, the thing is that at the back end, Amazon Web Services, they maintain a complete pool of public IPs. What happens is that whenever you deploy an instance, it automatically fetches a public IP. Without even you knowing that, it automatically gets a public IP, right? So what's the purpose of public IP? The concept, the purpose behind the public IP is that it allows you to gain access to the instances and the applications running upon it. You gain access to the instance or the applications running upon it over the internet. It makes your instances and its resources public in nature. Fine. Now, it's free of cost, no charge for it. And whenever you deploy an instance, automatically Amazon will fetch a new public IP from its pool and assign it to the instance. It's automatic in nature. But public IP comes with certain disadvantages. I'll pick the first instance as an example, and so that we can just focus on this instance, Linux instance, right? Now this instance that you can see right now, it has a public IP. Okay, I can use this public IP to get access to this instance using SSH, or if I deploy any Apache or any web application upon this instance, maybe Nginx server plus some WordPress site running upon it, anything I deploy upon it, any web application, I can get access to it on the fly. But the biggest challenge is that this is not static in nature, which means that if I stop and start the instance, this will be gone. And so what happens is that the public IPs, they don't interact with the instance on permanent basis. Let me show you this thing. And I'll discuss with you the real-time scenario that how it will impact the performance or the reachability of your website. So for example, I go back to the details, copy the public IP, and let me put that on a text document, right? So this is my public IP address of the instance. Let me do one thing. Let me just go ahead and stop and start it. I go to the action, go to instance state, and stop it. You will see that once I stop the instance, automatically the public IP address, which is a part of this instance, which ends with .15, will be detached from the instance automatically. It will be gone. Let's see. So this instance, once it stops completely, the public IP address of this instance will be detached automatically. Let's wait for a few seconds and see what happens. So as you can see that this instance is getting stopped, okay? And once it stops completely, you will see that the public IP address will be completely, it will just not show up. The private IP would be there, but the public IP would be just detached itself. It will just not be a part of this instance anymore. Now, you may ask this question, where it's gone, by the way. When I stopped the instance, before I stopped the instance, it was there, where it's gone. So when you stop the instance, see, there's already shortage of public IPs. There's already shortage of that. That's why now we are going towards IPv6 addresses. There's already shortage of it because public IPs are unique resources. Now, when you stop the instance, Amazon will assume that, okay, now because if any machine is stopped, there's no purpose of assigning it a public IP, which is a scarce resource, because you can't access it over the internet. It is stopped, right? So there's no point to have a public IP v4 address assigned to it. It's a scarce resource. So Amazon says, okay, you stop the instance, we'll just take it back and put it back into the pool of public IPs that we maintain at the backend. We detach it and put it back in our own set of public IPs that we maintain, okay, right? Now, when I restart this instance, you will see that now this time it will get a new public IP. When I restart the instance, you will see that it will get a new public IP. Can you see that? Immediately it got a new public IP. Immediately. Now, this may be a normal thing for you. This may not impact you, but sometimes this will impact you. Why or how? Let's suppose that, let me give you one example over here. So let's imagine that this is your AWS cloud infrastructure, right? This is the AWS cloud, and this is the, for example, this is the a Linux instance or EC2 instance, any instance, Linux or Windows. Now, the problem with the public IP is that, so what happens is, for example, you have installed upon it a kind of, you can see that a Drupal web application. So a Drupal web application is installed upon it. Fine. So a Drupal web application is installed upon it. Now, this is a website that people would access from outside. Now, what happens from your end is that you will be, this instance will have a public IP. So how the users will get access to the website? So for example, you have these external users. These are external or internet users. These are your end users who would be using your services. Now, how they will access your website? Now they will use a domain. Now, how you access facebook.com, google.com, you just type in www.facebook.com. So these users will, for example, type in, for example, your website domain xyz.com. They will say, okay, I want to reach, let's imagine xyz.com. This is your domain. Now this xyz.com will translate itself to the public IP address of the instance. Fine. So the user types in xyz.com and it will translate it to the public IP address of the instance. Fine. Now, what happens that if you stop this instance and restart it, then this domain has to be pointed towards a new public IP. Then in that case, if you skip doing that, then what happens? Your users will not be able to access your website. So this means that every time your instance reboots and you restart it, and if the website or the web application running upon this instance needs to be linked to your domain, then in that case, your domain has to be pointed to a new public IP. Now this adds on the overhead on you because every time, say, instance restarting is a very normal process. If you're doing some patching, some updation, some upgradation, you will just very frequently reboot your instance. Now, if you reboot your instance, restart the instance every time, and it gets a new public IP, if it's linked to a domain, the web application running upon it, then you have to link the domain to a new public IP every time, right? Now, how to sort it out? Because the public IPs are not static in nature, they are not reliable resources. So AWS says, okay, if you are dependent on the public IPs, why don't you use a static public IP that's called the elastic IP? So don't depend on the public IPs too much because they are not reliable. If you stop and start the instance, you'll get a new public IP. So if you want to get a static public IP, the other workaround is that you can attach the elastic IP address to the instance. Now the question is that how you can go about doing that. The answer is that you just go to the elastic IPs on the left-hand side. Now the elastic IPs are allotted to your account. You can see that there's a elastic IP allotted. Let me just, I think, yeah. So elastic IPs are allotted to your account. They stay in a region. So you need to allocate an elastic IP to the account first, and then you associate it to the instance. So I will say allocate elastic IP address. Okay. Now, network border group is nothing but it will say that, okay, in which region this elastic IP would be assigned to. In my case, it's US East 1. That's the North Virginia. And that's it. Click on allocate, and you will see that you'll get a new elastic IP address assigned to you automatically. Now, this is assigned to the account, not to the instance. It is not assigned to any instance right now because you can see that the associated instance ID is blank. Now, I need to just choose the elastic IP, go to actions, click on associate elastic IP, and I need to associate it to one of the instances. I choose one of the instances. Okay, choose the private IP address of the instance, and I click on associate. We'll also discuss the network interface afterwards. You can also link it to the elastic network interface if you want. Okay, but as of now, I'll be associating this elastic IP to one of the instances running in my account. Now, what happens? When I assign this elastic IP address to my instance, which already has a public IP. Okay, so this is the elastic IP. I'll be linking it to this instance, which already has a public IP. So if you assign an elastic IP address to an instance which already has a public IP, what happens? This public IP address would be detached automatically, and the elastic IP becomes its new public IP. I repeat my statement. When you link an elastic IP to an instance which already has a public IP, then the public IP address is gone, and the new elastic IP becomes its new public IP. The new elastic IP becomes its new public IP. Okay, let me show you. So I go to the elastic IPs and choose it, go to actions, click on associate elastic IP address. We'll choose the instance, choose its private IP, and click on associate. Now you will see that immediately it associates or it binds itself to the instance. I click on the instance, and you will see that now that instance which had the public IP address, it's no longer there. And this elastic IP that I just linked to the instance, it becomes its public IPv4 address. It becomes its public IPv4 address. Now, IPv4 addresses are out of 32 bits. So there are 10, 10, 10, 32 ones and zeros. So the IPv4, the public IPv4 address or the elastic IP is linked to this instance. Now, if I just stop and start this instance, you will see that there will be no change to this public IP because now it is the elastic IP, which is the public IP address of this instance, which is static in nature. So I go to this instance state and stop it. You will see that once I stop it, there will be no change. Once I restart it, there will be no change whatsoever. It will remain static. Now, the other advantage of the elastic IP is that you can achieve something called quick failovers between two different instances in the same region. For example, so this instance has my, for example, I may label it as primary instance. And then you have the secondary instance, primary instance or the secondary instance. Now the primary instance has the elastic IP assigned to it, but not the secondary instance. So for example, you have two instances, one primary, one secondary. Now your entire traffic goes to primary, and secondary is there just a standalone server just for the backup. Now let's imagine a situation comes up to you when you have to stop the primary instance for some time because you are performing some maintenance. Maybe it is it's not working properly. You have to upgrade some of the apps running upon it, maybe the operating system version. So this instance would be unavailable for few hours. Now the thing is that because there will be a downtime to perform some maintenance or patching, you want to make sure that there's no downtime. The users can still access your website or the web services running upon that instance. So you can say that, okay, I need to shut down my main instance for a few hours, upon which my main web application is running. Why don't I switch the traffic to the secondary instance for a few hours? So how can I achieve that? The quick workaround is that I just detach the elastic IP from the primary instance and move it and align it to the secondary instance. So I just switch, I take the elastic IP address off from the primary instance and put it to the secondary instance. What will happen? As a consequence, the traffic will be diverted to the secondary instance automatically. Okay. So how can I do this detaching and attaching? So first thing first, I will detach the elastic IP from the primary instance. Now, once I do that, you will see one thing. Once I detach the elastic IP address from the instance, automatically gets a new public IP. So let me show you the process. I go to the elastic IPs, choose it, go to actions and click on disassociate elastic IP address. Let me choose that and click on disassociate. Now, can you see that it's no longer being associated to any instance? And if I just go back and check out my primary instance, you will see that the primary instance has got a new public IP now. Now, can you see that the primary instance has got a new public IP? The elastic IP is blank, right? So whenever you take out the elastic IP address from an instance, immediately Amazon will give it a new public IP. Now, this elastic IP, which is now available and free, it is not assigned to any instance right now. I'll be attaching it to the secondary instance. And so secondary instance has a public IP, it will be gone, and this elastic IP would become its new public IP. So now this is free and available. I'll be attaching this elastic IP address to the secondary instance. And as a consequence, the user's traffic would be diverted to the secondary instance. So I click on actions, associate, and choose the secondary instance, choose its private IP and associate. Now you will see that now I've just switched my elastic IP from the primary instance to the secondary instance. The secondary instance has got this elastic IP, which is its public IP. This was previously the part of my primary instance, but now it's a part of my secondary instance. Okay. Now this flexibility you don't get with the public IPs. This flexibility you cannot achieve using public IPs, but you can do that. You can achieve that using the concept of elastic IPs. You can achieve that using the concept of elastic IPs. And also elastic IPs are static in nature. Now, coming to the billing part. See, elastic IPs are free of cost. You get 5 elastic IPs free each region, any type of account. It's a free account, it's a business account. You get a bunch of 5 elastic IPs per region. You can use 5 elastic IPs for free in each region, free of cost. And that's the maximum limit you can go up to. But the problem is that if the elastic IPs are assigned to stopped instances, or they're just sitting idle over there, then Amazon will start charging you. Let me show you. For example, I go to the Elastic IP. So you get 5 Elastic IPs free per region. But if I just disassociate this Elastic IP, for example, I go to Actions, click on Disassociate Elastic IP, click on Disassociate. Now, if I have this Elastic IP address unallocated to the instance for hours and hours, this should be free of cost. I get free 5 Elastic IPs per region. But Amazon will say you're wasting this. There's already a scarcity of public IPs or Elastic IPs. It's not assigned to any running instance. We'll charge you for that. You're wasting it. Okay. So the Elastic IP should be assigned to running instances. If you assign the Elastic IP to a stopped instance for more than 1 hour, there will be few cents charge being added to your bill. Okay. Few cents every hour. So Elastic IPs, you get 5 Elastic IPs free of cost per region, but you have to make sure that they are being assigned to running instances. They should not be sitting idle without being unassociated or not associated to any instance for more than an hour, and they should not be assigned to any stopped instance for more than an hour. Okay, that's the case. Now, if 5 Elastic IPs are that you get for free, each region is less for you, then you can order a bunch of 20 Elastic IPs as a package from Amazon for some cost. Okay, apart from 5 Elastic IPs which are free of cost, if you want to have more, you can order a package of a bunch of 20 Elastic IPs, but there's a charge for that per region. Okay. Having said that, this completes the concept of Elastic IPs. So now the question may be that if the Elastic IPs are not used, they're not being assigned to any stopped instance, how to prevent the further billing? So you can choose it, go to Actions and click on Release Elastic IP. Release means that you can release it from the account, but you not get it back. I think there's one option you can get it back within half an hour if you want. So I click on Release Elastic IP. So it says, if you release the Elastic IP address, they will no longer be allocated to your account, and you can no longer associate them with the resources. Click on Release, and they will be permanently released from your account. So that if your Elastic IP is sitting idle and you have to pay the charges for it, it's better that you release it. Fine. Having said that, this completes the concept of Elastic IPs versus public IP. So I think you got this thing. The next thing is the Elastic Network Interface. Now, this Elastic Network Interface is the interface between computer and internet network. So your machines is using a network interface card. It's called NIC card. Now, this NIC card, your computer, your machine to connect to the outside network. Okay. Now, the network interfaces, they have the IP addresses and the MAC addresses assigned to them. Now, your computers, your devices that we use all have MAC address. Now, where that MAC address is embedded on the NIC card of the device, right? Now, what happens behind the scenes that the instances have the primary interface attached to them, which carry all these options. Okay, so let me show you that thing. You don't have to deep dive into this thing. It's a very simple concept. See, every instance will have a primary network interface card attached to it. Let me show you. If I just can scroll down. If you just go to the networking details of the instance, the networking details, you can see that it's an interface. Now, this is the, okay, let me just discuss with you this thing. Now, let's suppose that, okay, this is my instance. Now, this instance will have an ETH0. Now, this would be my primary Elastic Network Interface, or ENI. Okay. Now, what is this ENI? This is a kind of a virtual NIC card, virtual network interface card attached to the instance. Now, what's the purpose of it? See, in actuality, the private IP, it carries a private, public / Elastic IP, and even the MAC address. It has a unique MAC address that it carries. So basically, it carries these properties for the instance. Okay, you can attach more interfaces to it if you want, but generally, nowadays I've not seen any of the very high scale applications being using multiple interfaces. Just a concept. You can attach multiple interfaces to the same instance. Okay. Now the thing is that that primary ENI, it's called ETH0. it will carry the private IP, the public IP, and the MAC address properties of the instance. Fine. Now let me show you that. If I just click on this interface ID, this is the primary interface. I click on that once again. Now you see that it will carry the private IP. Now this private IP is in actuality a part of the interface, but it shows up for the instance. The public IP, right? So basically it carries these properties on behalf of the instance, and also it has the MAC address. Show you that. Even the security group is assigned to it, and even the MAC address, you can see there's a MAC address. Okay. Now, what's the purpose of this interface? Basically, it connects the instance to the external network, maybe internet, because it carries the IP addresses, the MAC address, the security groups, right? So it allows the instance to be part of to access the outside network. Fine. So the elastic network interfaces are attached to the instance automatically once you launch it. You can also attach multiple interfaces if you want, but nowadays I don't think it will be of much use. You can create a new interface and attach it to any existing instance. But one interface is more than sufficient. It will help your instance to gain access to the internet outside.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ECT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
Now that we are done with the session, don't forget to subscribe to Intellipaat and press the bell icon to get the latest updates on Intellipaat.